I'm James Butler. I work for Mammoet as a project manager for nuclear and special projects as related to space exploration, space design.
So would you like to just jump into the video that you had sent me, and then we'll just go into some questions?
Let me start with this. So what I do for a living, and just to kind of break it down, I take your big stuff and I jam it in somewhere very difficult to put, and I put it very succinctly in a place with very small tolerances, very low tolerances. So I take something big, I move it, and then I set it down within 1/8 of an inch or 1/16 of an inch in some situations. Like for space, it's a 1/16, and typically nuclear, it's about 1/8 of an inch. And the best way to explain what I do, it's so hard to describe what I do. I try to communicate to people all the time, and it's very difficult. So what I did is I did a project in 2018 at Prairie Island Nuclear. And what we did is we lifted their generator. It was the oldest working generator in the United States. We picked it up from about 40 feet in the air. We moved it out and we brought a new one in. And this video really explains what I do, and it shows the level of engineering it takes to do this. And it took about 2 to 2.5 years of planning just to make this happen. So that kind of explains what I do. Big stuff, a lot of big toys, great big toys. The pieces that I work with are hundreds of thousands of pounds of equipment, and it's a lot of fun. I'm a civil engineer by trade. I'm a union operator, and I've been doing this since I was a little kid. My dad had a crane company, and that's where I started. So between that, I started as a kid in cranes, moved to Florida, worked for Disney and Universal Studios for a while. Then I went back to college and got my engineering degree, and then I started primarily doing nothing but heavy lift.
Do you mind if we jump straight into some student questions?
Not a problem.
All right. So I got some message to me here in the chat, and you guys keep them coming. And we got some email to me as well. One of the kids wanted to know, what is the biggest thing that you have ever had to lift?
Biggest thing I personally have ever lifted is a dam segment. My first job out of college was at a dam in Kentucky, and the pieces were 120 by 102 by 50 foot tall, 60 foot tall, and they weighed 5,200 metric tons.
And what is the process of that? Like when you're lifting a water dam like that, like does it take?
It's like Legos.
Just
it doesn't. It takes a long time to build the piece, but how to put it together, it's actually on the internet. It's called the Olmsted Lock and Dam. And if you want to see it, those pieces were actually videoed, each piece that I was a part of. It's a giant crane, and it's a slow process of doing the engineering and picking it up. But yeah, it takes a long time to figure out how to pick things up without breaking them. You know, so this dam was put together like Legos. So when you put Legos together, so we built it on land and then moved it into the water and set it across the Ohio like Legos.
Now, as someone who's interested in working with big machinery, what kind of advice would you have for the kids as far as what should they study in high school, and then when they go on to college, what should they study?
The biggest thing to do is to get out there and get a small construction job. Start out with small, working for somebody, even cleaning garages. I started out cleaning garages with a Bobcat. I had the advantage of my father owning a crane, so I was on that. But if you want to, in high school, get a start, work for a construction company. Learn all you can about equipment, how to run dozers, how they work, how to change the oil. I mean, just anything you can learn. And then going through school, if you go to college, don't try to rush through college. Don't. Everybody wants to push you through college in like 3 or 4 years. Don't do that. Take the time, do internships, make sure you know what you want. Those internships will define you later in your career. Not the education, the internships that you take, the time that you take learning while you are applying what you're learning theoretically.
That's very interesting. One of our kids had emailed me and they wanted to know what stuff, as far as specifically space related, have you had to?
Oh, sure. Everybody's familiar with the old space shuttles, right? I'm assuming everybody knows space shuttles. So the space shuttle had a big platform you used to sit on, and there was a crawler underneath it, right? Called the NASA crawler. So the piece was called the MLP, Mobile Launch Platform. So you'd see it like traveling with the space shuttle. You know, everybody's seen that picture. And so there's 4 of those launch pads. Okay. And what I specifically did for NASA is that we took, the crawler was 20 feet in the air tall. The actual MLP, the Mobile Launch Platform, was built at 20 feet tall. They're no longer using them anymore, and they had to bring them to the ground to destroy them. So what I've done is I took it off the crawler traversed out, and we brought it to the ground within 4 feet so they could demo it at a much lower area. And what else I've done for space is Blue Origin. Everybody's seen Blue Origin, Amazon. At Cape Canaveral, my company and my projects, we set the launch platform up. We actually moved the launch platform in place, which was 1,500 metric tons, and then put the launch table where the rocket sits on, which was 800 tons. So we delivered all that by barge, traveled it through Cape Canaveral, and set it down.
And I would imagine, I'm assuming that you've already answered this, but I'm going to go ahead and ask this anyway. Can you tell us about the most difficult project that you had to work on?
Man, most difficult project I ever had to work on. I think it was my first nuclear power plant. Learning the rules and not having a mentor at the time. Nobody I'd ever worked with had worked in nuclear, and I didn't have a mentor. and learning all the rules and all the regulations and making mistakes. The mistakes that you made there had huge consequences. So the most difficult job I ever did was loading a steam dryer, which is at what's called a boiler water reactor nuclear power plant, and it dries the steam so that it doesn't rust the blades on the turbine. And it's screaming hot with radiation, screaming hot. And we had to pick it up with a crane operator who had lead all over his cab, couldn't see it. I had to direct the pick on a radio, direct the lift on a radio, and I had an inch of clearance to get it out and in place to be transported to Utah. That was my hardest project, hands down.
That had to be absolutely terrifying, because I can imagine how the dangerous implications if something goes wrong.
Yep. There's a picture of me 5 minutes before the lift, and this spot right here was brown, and 5 minutes later it was white. That's how much stress it was. So yes.
That's crazy. We have a question from Marco. Marco is in Spain. Marco, you can unmute to ask. You had a pretty good question. Go ahead and ask when you can. You might be.
Yeah, that's it.
Okay.
I wonder how much money it cost to move a big weight due to the energy it uses.
He wants to know
So how much money?
Yeah, does it cost to move something so massive?
Okay, so I'll let you in on a little bit of proprietary stuff. So that video you watched, that video in a rough order of magnitude is an $8 million project. So that's, a rough order of magnitude when you have something that great. It can be as small as 500,000 to, we currently have a job building a wind farm, which is 50 million. It just depends on the complexity, for space, Blue Origin. I mean, you're talking $5-6 million to build a launch platform. It's very expensive. I mean, for Amazon, let's be clear, it's not expensive. Okay. We're the small, in a big project like that, the heavy haulers, which we're called heavy haulers or movers, are the smallest part of it. So like $5 million to a $500 million launch pad really isn't that expensive. But to you or I, especially me, because I have 3 kids, it's very expensive.
Oh, absolutely. It's expensive to the 99% of everyone else in the world.
Yeah.
So one of the kids wanted to know, is math a huge part of your job?
It's everything. And when I say it's everything, I mean it's everything. And I wasn't very good at math. Actually, Mr. Krause's mother tutored me in math. That's not a joke. That's serious. She tutored me in math, and she was great at math. And it took me a long time, because I went back to college, to really understand what it meant to be a student. And you learn all this theoretical math, and you're like, oh, geometry. It's stupid. It doesn't. I'm never going to use this stuff. Well, a lot of math you don't use. But the concrete stuff you guys are learning right now, I use geometry every day. Every single day I use geometry. Don't underestimate the fundamentals of math. It's not the integration, differentiation. It's not that stuff that defines our world. It's the basics. Order of operations, geometry, algebra. Those define our world, not all the other theoretical stuff.
That's good advice. We have we'll go with a couple more questions, then we'll let you go. But one of the kids wanted to know if you could explain, because you've been in engineering for a bit, obviously with your father's company you mentioned. Have you seen technology evolve the industry over the past few decades of lifting heavy materials?
Yes, especially in jacking. So before, it used to take giant cranes to pick things up, or giant winches, sort of like in that video you saw a winch pick up that generator. They have systems now that are like a box, just like Legos, and they push up, just like these crates. They look like milk crates, and they stack from underneath. So you put one in, it stacks it up, stacks it up, stacks it up, stacks it up, where before it would take a monstrous crane. Not to mention the computer platforms, SolidWorks, AutoCAD, MicroStation, all those. By the way, speaking of that, if you have an opportunity to learn those early on, you will have a huge jump on other competitors trying to get jobs in any type of engineering, civil, mechanical, anything. Learn those platforms if you had the opportunity to someone to teach you.
That is some pretty solid advice. And so one of the younger kids, maybe you can simplify it. And I know you've tried to answer this. One of the real young kids, they want to know, how do you lift all the heavy stuff? If you could simplify it.
You work real hard and you think for a long time and you figure out a way to grab it. Just like when you're playing those games that grab the stuffed animals out, you know, you take those claws, right? And you're looking at all the stuffed animals you want. And you position that claw and you position it right in the right spot and it gets it. Sometimes you lose it, sometimes you don't. In my world, we can't lose it. So we try to make sure that claw is right in the right spot. Does that help?
Yeah, that pretty much sums it up. That helped. Not only did it help the students, but I believe it helped myself. And so thank you for that. So before we let you go, because I know it's getting kind of late for our kids around the world, is there any advice as someone who is so accomplished as yourself in your field, getting to do so much cool stuff, and you get to travel all over for your job, which is super cool too. What kind of advice would you have for these kids as they go off into the world and figure out what they would like to do?
Define your passion. Don't just take a job because it has a big paycheck. Paychecks run out. Your passion never does. What I do, I absolutely love. I absolutely love it. I love it every day. And what I love about it is I get to keep people safe. I get to add to our world in a positive way. And those are things that are dear to me. Find out what's dear to you. It might be design. It might be planning. Whatever it is, find out what's dear to you. Don't compromise passion for a paycheck.
That's solid advice. And I'm gonna unmute everybody so we can all say thank you to James, and then I'll end the meeting for all, and we'll provide a recording to this and it will be sent out to everyone who registered for this. So before we go, can we all say thank you to James for taking time out of his valuable day to talk to us guys? Thank you so much.
Thank you so much.
Thank you, James.